Welcome to another video. I got a comment recently on one of my videos asking to maybe discuss some instrument-related material. As I state in my other videos and talk about, the primary purpose of this channel is to help you relax with it leaning toward an aviation type theme. It's not really a channel I feel is appropriate for studying or gaining information that you may... I just don't want to be considered a source. With that being said, aviation itself is a very broad topic. It's very complicated. There's so many specific fields and so many different topics as part of aviation as a whole. That's one of the most wonderful things about it. But with that said, the comment got me thinking, because I know it's been a while since I've posted a video, but I really have struggled to figure out what kind of video I want to post. It's aviation, really. I've thought about maybe doing a pre-flight type video on anything from a twin piston to a Learjet or a Embraer or something like that. And that's a potential video down the line, but before I digress too far, I decided, based on one of the viewers' suggestions, that yes, indeed, I was going to, I thought maybe discussing some instrument-related materials would be make a good video. Instrument can be rather dull sometimes, so if the video of the sounds and such aren't enough to relax you and put you to sleep, maybe the material will be dense enough that it will. But so today, I figured let's look at some approach plates. I've selected two here, and well, I normally use what's called an electric flight bag, an EFB. I chose to print these out. It's easier for the camera and such to focus on and not have any kind of strange things going on in the video. So I printed them out on paper. It was printed out on a black and white laser, so this approach plate is not a problem. However, this approach plate here has some terrain that if you were looking on an electric flight bag, or a actual printed out chart, it would be in color, it'd be brown. But I don't think that's a huge deal for the purposes of this video. So, like I said, we're gonna go over these two approach plates today. We're not gonna dissect them all completely, but we'll certainly go over a number of different specifics. And maybe for some of you who are watching, you might get your memory jogged, or maybe even learn something a little bit new, maybe. But again, I'm not a source for when you're going on your check ride, or you're going up for recurrent or something like that. But anyway, so I figured two approach plates today, and if the video was well received and I'm asked to do some more with this particular theme, I figured maybe we could go over like an arrival, obstacle departure procedure, things of that nature. So without further ado, let's get going. So the first approach we're going to look at, I'll move this aside, keep our little Southwest 737. We'll go ahead and start with the RNAV, the GPS runway 28 right into Montgomery Gibbs Executive, which is in San Diego, California. used to fly in and out of this airport all of the time. Didn't really fly this approach too often, but it's, this airport is certainly something, an airport I've logged a lot of landings in and out of. So, interesting that we're starting with the GPS. Normally it's the other way around. We start with the ILS, the ground-based NAV type approach, but hey, we're in the 21st century now, and we are slowly but surely transitioning to GPS. So, as I said, GPS runway 28 right. We would, of course, make sure we have the most current and up-to-date chart or approach plate. This approach plate was amended on the 20th of February of 2019, so this year, at least the year I'm making this video. And it's valid. Well, I guess the 737 is going to have to fly away for a little while. So, if you look on the side here, it's dated the 25th of April 2019 to the 23rd of May 2019 is when this chart is valid. And as of right now, as of this day being, it is the 1st of May. So this plate is valid and up to date. Now, we'll kind of go through a modified approach briefing. I may stop along the way, kind of go into further detail about what I just said, but we'll start from the top. So our approach course here is going to be, our final approach course is going to be magnetic heading of 281. We've got 3,399 feet of usable runway. Touchdown zone elevation is 423 feet. And airport elevation is 427 feet. Now, the runway at Montgomery, 28 right, is actually longer than 3399. And if you come down here and look at this small airport diagram, you can actually see 28 right is 4,598 feet long. So according to this, we've got a considerable amount of runway that is essentially unusable to us for the purposes of landing. It's because this runway has what's called a displaced threshold. For those of you who don't know what a displaced threshold is, it's pretty much where the aircraft can touch down is further down the runway from where the actual pavement starts. A displaced threshold, the portion that can't be used for landing can be used for things like takeoff and taxi and such, but it can't be used for landing, and a lot of it comes down to terrain, obstacle clearance based on the approach and the glide slope. Other times it's because the infrastructure, that portion of the runway, actually isn't able to support continuous landings of aircraft. It does wear down the runway over time. So there's a couple reasons for it. But in this particular case, it doesn't really matter the reason for it, but we do have to understand that there is a displaced threshold here for runway 28 right. It's an RNP approach, required navigational performance. When we're shooting this, we should see, with any luck, LPV navigational performance from our GPS. And of course, most aircraft, based on your route and your input, should automatically tell you if you don't have what's called RAIM, which is required autonomous integrity monitoring. I believe it's to make sure you're going to have the required navigational performance from your GPS upon reaching your destination, and that's going to go off the number of satellites that your GPS will be able to receive signal from. But this is more or less leading us down a slippery slope. We're not necessarily a slippery slope, but digressing to a topic that I could spend easily an hour talking about, but I don't really feel like talking about it. Anyway, we have non-standard takeoff minimums, non-standard alternate minimums as well. As symbolized by the T and the A here. Now, this is the notes section. It's telling us that runway 28 right, helicopter visibility reduction below 3/4 statute miles is not applicable. And for uncompensated Barrow VNAV systems, LNAV VNAV minimums are not applicable below negative 15 degrees Celsius or above 54 degrees Celsius. Without even going into what that exactly means, negative 15 degrees Celsius or 54 degrees Celsius is unlikely in Southern California, especially the negative 15. I mean, 54 degrees Celsius is pretty hot, but still overall the likelihood, and especially this airfield sits in very close proximity to the Pacific Ocean. But regardless, it's still required to be in there. This is telling us here what kind of approach lighting system we can expect when shooting this approach, when we see the approach lighting system or the runway environment setting. In this case, it's a Mauser lighting system. It tells us this because there's different approach lighting systems, and as a professional pilot, but even a recreational one with an instrument rating, you should have a general idea of what the approach lighting system looks like. In this case, for example, the Mauser lighting system, one of its core features, I guess you could say, is that it has a sequencing rapid light flashing, kind of, flashes 1, 2, 3, 4, 1, 2, 3, 4, kind of pointing you in. And that should generally be the first thing you'll see when you're getting down and getting close to minimums and such. It's usually the first thing you see on an approach or an approach lighting system. We'll come back to the missed approach here in just a few minutes. Now, of course, before commencing this approach, we want to make sure we have got our weather, our ATIS, which is broadcast on VHF frequency 126.9er. This is a Delta class airport with a part-time control tower, as symbolized, I believe, by the star here. You can also kind of piece it together because if you notice it says 119.2 for tower, and also in parentheses it's a CTAF, a Common Traffic Advisory Frequency. The L also means pilot controlled lighting as well, so this is, all of this put together can kind of tell you this is a part-time control tower. Now, regardless, if we're executing this approach, we are going to be controlled. Alright? When we start the approach, we should be talking to SoCal approach on 124.35. Additionally, we've got our ground control. So say we start the approach, get switched over to tower 119.2, then you want to have it back up COM 2, or just ready to switch over on COM 1, 118.22. Clearance delivery frequencies 123.72. And then San Diego Radio Flight Service Station is 122.4. So you might be asking, okay, well, why do we need flight service if we've got SoCal, potentially a tower? Well, chances are we don't need flight service at all if the tower is open. But depending on where the radio towers are in proximity to the airfield, and then given the topography of the area, which San Diego toward the coast is not too mountainous, but there's certainly changes in elevations, as you can see. Various structures and then terrain are indicated. So 577, and then over here 1178. So there's the potential that should we be flying this approach at a time when the common traffic advisory and advise when on the ground, either through flight service or by contacting us on SoCal Approach. Now, sometimes, depending on the airport, when you get on the ground, you are unable to get adequate reception to talk to SoCal. So, at that point, what you'll want to do is contact Flight Service San Diego Radio 122.4. That's a lot of information just in that bar right there. So, now let's come down here. This kind of gives you the bird's eye view of what the approach is going to look like. And when you're loading up this approach in your GPS, it's always a good idea to pull up the map view and verify everything kind of coincides and looks like what it looks like on your approach plate. Now, there's a couple ways we can generally go about flying this approach. Generally speaking, especially if you're in Southern California, there's no way you are going to start at a feeder fix or sometimes even an initial approach fix. They may just vector you onto the final approach course outside of the final approach fix, which in this particular case is Penny. But for the purposes of this video, academia, I guess, we'll say we're going to start from a feeder fix. I apologize if you can hear aircraft in the background. I don't live close to a particularly busy airfield, but it's getting to pretty much the last hour or so of the day where the last of the commercial flights and such are leaving. So now let's say we're going to start at Barrett here. Okay, Barrett is a feeder fix. Now there's a couple ways we can figure that out. First of all, you see it says Barrett and nothing else. There's no parentheses by it. Secondly, it's got a thinner solid line as opposed to these thicker solid lines. Now this is actually kind of an interesting example because a lot of times feeder fixes don't have fixes between them and an initial approach fix, which the instrument or initial approach fix here is Bakel. Now the reason that this feeder route does have a fix in between Barrett and that initial approach fix is because of altitude changes, going down to an MDA, minimum descent altitude. Now here from Barrett to Gote, you can see right here it's telling us we can go down to 6,100 feet. And from Barrett to Gote, that's 4.3 miles, nautical miles. Now from a Gote to Bakel, we can then descend down an additional 200 feet to 5,900 in 4.2 miles. Now you might be asking yourself, well, that's only 200 feet. Well, what's the purpose? Well, a lot of it comes down to potentially the type of aircraft you're flying, how fast it goes. You don't want to be diving the aircraft, and if you can get lower, it allows for with less altitude to lose by the time you land. Further out, it makes for a more stabilized approach, which is, of course, what we're always going for. Now, from a Gote to Bakel, we can go down to 5,900 feet, at which point, when we hit Bakel, we have hit the initial instrument approach fix. Now, before I get any further, you'll notice these symbols, these 4-point star-like symbols, right? And then, if you notice, and it's probably kind of difficult to see, given that the camera is a little zoomed out. But an example is the airport here, also symbolized right here as that 4-point star as well. encased in a circle. The difference is these are considered fly-by GPS waypoints. The 4-point star encased in a circle is considered a fly-over waypoint. Now, what's the difference? Well, for example, here, once we are coming up on Bakel from Agode, we obviously need to turn roughly 90 degrees or so from a heading of 257 to a heading of roughly 197. Now, if we were to wait to make that turn at Bakel, and in this case, let's say we're doing 180 knots. Alright, if we wait till we hit Bakel to make that turn, there's a good chance we're not going to actually be able to make that turn down to 197 fully until we're potentially a mile away from that intended course. Alright, so at this point we've deviated, we're off the approach. So we need to start this turn before we hit Bakel. Now, the beautiful part about GPS is it's going to tell you when to start turning, and it does that utilizing computations based off your ground speed and such. Now, for the purposes of this video, we'll say we're doing 180 knots at this point, which is, at this point in the approach, is a decent speed. 180 knots divided by, and we're going to divide it by 2, so that's 90. Okay, so we go 90 knots, we put a decimal in front of 9, so 0.9. At 0.9 miles out from Bakel, from Agode, we're going to start a standard rate turn to the left, and we'll fly over Bakel, and then continue to drag down to 197 to Mibby, which is an intermediate fix. Same thing. Now, you don't actually have to calculate that, but that's probably where the GPS, at what point the GPS is going to tell you to turn, in this case 0.9 miles out from Bakel if you're maintaining 180 knots. So, we continue. At Bakel, we can ascend from 5,900 down to 4,200. Then we turn inbound on our final approach course of 281 from Mibby to Nesty. We can continue to step down to 3,600, and so on, and so on. So, from our feeder fix to our initial approach fix to our intermediate fix, turning inbound on the final approach course, which is 281 degrees. Now, the step downs all the way to minimums, or minimum altitude, or decision altitude in this case, because for the purposes of this discussion and approach, we're going to plan the LPV minimums, which is not a MDA, it's a DA, decision altitude. But this view actually shows you the various step downs. So we'll say we've turned inbound on the final approach course, 281, from Mibby. From Mibby to Neste, 3,600. From Neste to Penny, which is our final approach fix. Now, since we're intending to shoot the LPV, which is considered a precision approach, the glide slope intercept altitude of 2,500 is our final approach fix, which happens to coincide with Penny, the Maltese Cross, which would be our final approach fix for the LNAV, VNAV, LNAV, and then the circling approach. So from Penny, we can descend down. We'll follow our glide path. Always remember there is a distinction in the way a glide path is depicted versus a glide slope on your typical glass display. Is a glide path will be magenta, and a glide slope will be green. That's not end-all be-all ominous dominus, but it's pretty typical, especially amongst general aviation avionics equipment. changes. If you're flying good old-fashioned analog with, say, an HSI, the glide slope's not going to look any different, but there is a difference between glide slope and glide path. And without getting too far into it, it comes down to where the information comes from and how it's deduced. In this particular case, this is a WAS approach. So it's all satellite-based navigation. I'm going to stop right there. We'll just continue to brave this approach. So from Penny, we'll follow the glide path down to our decision altitude of 673 feet. At that point, if we don't have any indications, the approach lighting system, the runway environment, the airport, anything 91.175 states, at that point we will then execute the missed approach, which is depicted here in the dashed line, but it's also textualized up here in the right corner, and then it's even kind of briefed down here. And it says missed approach climbing to 3,000 direct Jupdo, which happens to fall on the same heading of 281. We'll proceed direct Jupdo at 3,000 feet, and on track to 327 to KMYF and hold. So Jupdo, we take a right 327 up to KMYF and hold, and we'll assume 3,000 feet. Now this is Southern California again. They will have you you'd probably make it 2 or 3 miles on this missed approach segment before they'd already start turning you around, either for vectors to retry, or if you need to deviate to an alternate, maybe you're going to go to Gillespie or Palomar or Brown, or, if you want to pay for it, in San Diego you can go pay signature service, because they're going to love charging you for your overnight fees and your security fees and so on and so forth. So that's for the purposes of shooting that LPV going missed. And now it's important to remember, and I feel like in my experience in the past when I used to flight instruct, it's very easy for those going through instrument training and flying this to always get in the mentality that getting ready to go missed, and much like always be prepared to go around when landing, you must always be prepared to go missed, but don't plan to go missed. Plan to land the airplane, because oftentimes pilots forget the whole point of shooting this approach is to land. We're not just doing this for our health, we're doing this to land the aircraft. So they may forget to configure the aircraft, they may forget to even slow it down, at which point when they say they hit minimums and they do see the approach lighting system, or they see the runway, they realize, good God, I'm 40 knots faster than my landing reference speed. I've only got 3,400 feet of runway to not only slow this thing down, but also to get it on the ground and then stop it. There's just no way. I mean, unless you're in Skyhawk. And even then, if you have opted to shoot this approach at, say, 110, 120 knots, that's still quite a bit of speed to bleed off, in which case the argument can be made that you're violating 91.175 because the aircraft is not stable. You're too fast. You're going to have to make aggressive changes in flight configuration and